Well, thanks for coming. Welcome to the session on migrating to Java modules, why and how. I'll spend a few minutes talking about why we should really be serious about modules, and then I'll spend most of the rest of the talk talking about how to actually do the migration, some of the things we need to really keep in mind. A lot of these things came out of my experience working with organizations where we took applications from Java 8 all the way down to Java 11 and Java 12. A lot of interesting journeys, a few do's and don'ts, so I'll talk about some of those things along the way. So the first question is, why do we really need modules? And the point I want to emphasize here is modules predominantly were created not for you and me. This was really created for making Java itself modular. So if you were to take a look at the rt.jar in Java 8, that is, depending on the version you're looking at, about 68 megs in size. Do raise your hand if you use swing. A few hands went up. Raise your hand if you use Corba. Didn't see any hands go up. One person is kind of waving like, why? But the point really is, the good news is this: if you ever wake up in the middle of the night and say, I wish I had it, it is there waiting for you in Java 8. Well, that's like going to somebody who's going on a trip and telling them, take these 7 luggages with you. And they ask you why, and you say, don't worry, if you ever need things, it's in there for you. Well, that's not a way to really develop applications, so they want to modularize Java. So the very first thing I want to start out by showing here is that I'm using Java. Let's look at the version I'm using here. It says version 11 in this particular case. But on the other hand, I'm going to say Java list modules, and I'm going to just run these list modules. And this is going to tell us all the modules that are part of Java without even any application code, and that's the list that you just saw over there. And I'm going to just ask for the number of those, and depending on the version you are looking at, in Java 9, give or take 97, 98 modules. Java 10 has about 78 modules. Java 11 has about 70 modules in it. So that is Java being broken up into smaller pieces. And by looking at the list modules, you're able to get the list of all the modules. If this had my own application modules, the number will be higher than 70, obviously, because it would include the JDK modules plus my own modules as well. Well, so as a result, rather than having this one big ball of mud or a monolith being available to us, we have all these little modules that we can pick and choose what we want to use and don't have to care about things that don't matter to us in our application. So that was the very first reason why they wanted to do it. The second reason is that it is a way for us to have a better modularity in terms of setting up boundaries, what you can use and what you cannot use. In the past, when people told you, this is not public, don't use it, it was more of a recommendation, and people kind of always started using things. Well, modules give us a very stricter boundaries. The third reason for this is a better security. For example, if you have created a package and I really want to use some of the classes in your package, I can create a jar file with the same package as your jar contains. And when you run the code, what does Java do? Java looks at these two jar files and says, this is kind of interesting. The package is across these two jar files, and it shrugs and just walks away. That's not going to be really making things more secure, but it's really hard to go back and make what exists secure. It's a lot easier to introduce something new to make it secure. And the next thing to think about is that when it comes to Java, how does Java work in the past? I'm going to say Java in the past worked in the in-law mode. And what I mean by that is you took all this time and effort to build your application, which contains, let's say, 80 jars. And you gave it to your build team to deploy it. And while they're taking it to deploy it, they drop 1 or 2 jar files on the floor, and they deploy the rest of it. What happens? Your application gets deployed, and it keeps running for a while. Until 2 a.m. on that fateful Wednesday morning, somebody clicks that forbidden button, and it says class not found exception, and your phone rings. That's no fun at all. Well, you want things to fail fast, and I'm going to say that Java runs in the mother mode now. It will check to verify everything is in place. Like you're leaving home, she comes to you and says, I know you have a busy day. Don't forget the key. Take it with you. In the past, Java was like, oh, she's forgetting the key. Wonder she will find out. I'm going to wait and watch. That's not a good way of developing systems. You want this to be fail fast, and that's exactly what Java does. And I'll show you some of those things along the way. So what is a module? A module is stuff you create, just as simple as that. Your classes, your enums, your interfaces, your data, your stuff. Everything you create, you can put them into modules. And a module typically has this particular constraint that a module requires other modules. And a module will export its packages. And that is something you need to keep in mind. You never require packages. You never export modules. And what that means is, as a person creating a module, you decide what goes into that module. Imagine that I'm going to FedEx something over to you. I get to decide what goes into that box. That's kind of like modularization. What do you get on your side? I'm hoping you get the full box. You would be very unhappy if you get one or two items and don't get the rest of it. That's called US Postal Service. That happens to me quite often. And they will say, be happy we sent you at least this part. Well, the point is, the one who ships you decide what to package, but you get the whole. This is based on what's called the reuse-release equivalency principle. So what you get to reuse is the whole of what is released, not bits and pieces of it. So you export packages, and the other side, you receive or require modules, and that's the way to communicate. Now think of this as a handshake. Just because I extend my hand doesn't mean we shake our hands. Just because you extend your hand doesn't mean we shake our hands. Both of us have to extend our hands. So in that regard, one module has to export the stuff it wants to export. The other module has to require it, and then comes the handshake. You cannot use what's not exported. You cannot use what you did not ask for explicitly as well. So the boundaries are pretty clear when it comes to modules. So I talked about the why so far. Let's jump in and look at how we can actually do this. So I want to start by looking at quite a small example of defining modules. Now, in realistic terms, we would typically use a tool to build our code. You might be using Maven, you could be using Gradle, you could be using whatever you want to do. I'm not going to do any of them for a simple reason. I want to absolutely look at the raw things. I don't want to have any things that hide the details. So I'm going to be just using command line and build things so we can actually see the bare metal of what we are really dealing with. Obviously, in production, we would use tools to make our lives a lot easier, but in this case, it gives us a clarity on what we are dealing with. So how do we go about using this? So what I have here in front of me is this directory. I have a build.sh, just a simple shell script file. I've got a first directory, I got a second directory. If you look at the first directory, all that the first directory contains is a package called com Agile Developer first, which contains a first.java. Similarly, if you notice what is in the second, it contains a second as a package and then second.java. So nothing really exciting so far. Let's take a quick look at these two Java files before we go any further. So the first is extremely trivial. It says get info. It returns first to you. So I just want to know if there's life. We are able to communicate with this class. That's all I have in the first. On the second, if you notice, I've got a main. It calls a get info on the second. It calls a get info on the first, and we are returning it. Now, with these two classes, what am I going to do? I'm going to go ahead and compile this Java C minus D, just like the way we normally compile Java code. And I have a jar to bundle up into first.jar, and I just blow away the classes directory. I compile everything in the second directory at this point, which is going to be in the second directory, and then bundle that into a second.jar. And then once I'm done, I'm running it in the class path. That's all I'm doing. So go ahead and run the build on this to be sure it's working. And there you go. It worked. Nothing really exciting. What did I prove so far? What I proved so far is life is as usual. I did not write the code any differently. I didn't build the code any differently. The only thing I did was I ran it in Java 11 or Java 12, depending on the version you are using. You can run it in that particular version. So in other words, they made it so easy for us to take what worked before and continue to use it moving forward. So if you are running your code, compiling your code, and you're saying, you know what, I'm just not ready for modules on this project, don't force yourself to do anything. Just run things from the class path the way you did. But of course, if I want to use modules, what do I do? That's the next question. So in that regard, I want to kind of set the stage for two different areas of execution. The class path is the legacy. The class path is the old stuff. That's where everything resides. And then you have what is called the module path. So imagine for a minute this room. Let's divide this right in the middle. Imagine this is the class path, what we had before. Imagine this is the module path, what we have right now. So you have these two areas. The class path is legacy, traditional, what worked before continues to work today. The module path is the new one, more secure, a region of high privilege, but high restrictions as well. So when you run your code, you get to decide where you want to put your code. You can put your code in the class path and run it, or you can put your code in the module path and run that as well. So in this case, notice what I'm going to do. I compile the code like the way we normally did, no difference at all, but I'm going to change this class path to -p. And P stands for module path because it's so descriptive. So this is basically a module path, and you're going to put this in the module path right now. So I just said -p. One of the other things is when you typically put things in the class path, you probably are that person in the company who has this absolute luxury of listing every single jar file. That's a fun job to have put on the resume, right? Well, you don't have to do that with the module path. You can specify individual directories, you can specify individual jars, or simply point it to some directories. So notice I got rid of everything except the directory location in there. That's perfectly fine as well. So now I go back and run the code one more time, and in this case it gives me an error saying I cannot find what you are talking about. Well, the reason is now everything is in the module, not in the class path. So what am I going to do? I'm going to go back to this code now and say a -m. And what is the name of my module? Second, because that's what I'm running. And then I specify com.agiledeveloper.second.second. So I provided the name of the module. Of course, you may wonder, how in the world do you know that's the name of the module? We'll come back to that in just a few minutes. So I'm going to go back and run this code this time and see what it tells us. Notice it ran one more time. Well, notice I didn't change anything in the code. I didn't change the way I even compiled the code. All I did was took the old jar file, ran it in the class path, and took exactly the same old jar files, no change to it at all, dropped into the module path, but when I ran it, I made one change. I gave a -m and the name of the module. Now, how do I know what the name of this module is? If you look at the output mlib directory, the name is called second.jar. And you may say, aha, I got this now. The jar file is called second.jar, and so the name is called second. And there's a name for it. That's called a guessing game. And it never works so well when we do that. Because what if somebody names this second-all? And then you're like, okay, should it be second-all? And then Java will tell you, no, it is second.all. You will never win this battle, and it becomes really frustrating. So what do? Well, here's a great news. You say jar, but you do a -f, and then you specify the file name, output mlib, second.jar, and you ask for a -d option. Now, this is a really useful option. That is what I would recommend using. So run the jar, -f, point to the file name, and just use the -d option. The -d option is reveal your secrets, give me your metadata. That's exactly what it is. So jar files have metadata that they carry for modules. If they are very old modules, there's a convention that kicks in because the metadata is lacking. But the convention is decided by Java. You and I don't have to guess it because -d tells you what that convention is. So when I ran this, notice what it tells us. It says no module descriptor found, derived automatic module. I'll talk about that in a minute. It says second automatic, so it tells me my name is second. Just to illustrate the point, if I move this to output mlib, second to output mlib, second-all.jar, just to kind of entertain the thought here, and I go back and query this time the second-all -d, notice it tells me my name is second.all, not a -all. So again, you and I don't have to fight that battle. Use the -d option, find out what the name of the module is. You don't have to be guessing. So this is true for existing modules. Now, that readily leads us to understanding something else. We have already seen quite a few things. We ran the program in the newer version of Java, but we ran it in the class path, and we ran it in the module path. So the obvious question is, what are we really looking at? So what we need to be very comfortable with is that there are three types of modules available in Java. The first one is called unnamed modules. So what is an unnamed module? Unnamed module is everything that sits in the class path. And by the way, you can have a lot of modules in your code, but there is exactly one unnamed module. So everything you dump into the class path gets together into this one big happy family called unnamed module. So every one of them is part of an unnamed module. And that's what runs in the module path. On the other hand, when you run it on the class path, when you run it on the class path, it's an unnamed module. The second thing is, you take a very old module and you drop it into a module path. It wakes up and says, oh my gosh, I'm in this new world of a module, but I'm still the old code. What am I? Well, you now become what is called an automatic module. And an automatic module is an old jar coming to life in the module path. So module path is stuff in the class path is the unnamed module. Automatic module is old stuff in the module path. So that's how you know whether it's an automatic module or whether it's an unnamed module. And a third thing you're going to create is called the explicit named module. So what is an explicitly named modules? Explicitly named modules, if I know how to spell explicitly, explicit named modules are new stuff in the module path. But more important, what makes it new is has what is called a module descriptor. And I'm going to get to that part in just a few minutes. So this is really the summary of the world of modules. You got three types of modules. The unnamed module is just one of them, and that's a big happy family of everything that runs in the class path. Automatic modules live in the module path. They are still old stuff running in the module path. And you describe a module descriptor, that becomes an explicit name module. This also represents the degree of restrictions and capabilities. The most restrictive is the explicit name module. It follows rules very rigidly. The automatic module is like kind of quasi, a transition period. I was old, but I'm graduating to being new. Give me a footstep for me to climb up and go. And the unnamed modules is the least privilege. Now, this changes how we use application, how we move from old code to the new code moving forward. All that is going to change as well. So we'll talk about some of those things as we go along. But before we do that, let's just experiment a little bit to get a feel for it. So I'm going to go ahead and comment this out for a second. And I'm going to say Java minus class path one more time, output / mlib, and this is going to be first.jar, but I'm also going to bring in output / mlib, and then I'm going to bring in the second.jar as well. And then, of course, I'm going to bring in com Agile Developer second.second, so we can just run the code in the class path like we did a few minutes ago. So let's go ahead and fire that up and run that and see what it tells us. It ran. But what I want to look at here is just one more detail, if you don't mind. Let's go to the get info for a minute, and we'll say first, and then we'll say plus, and we'll say this get class, and then we can say dot get module, so I can query for which module this code is running. So here's a quick quiz for you. I'm running this whole thing from the class path. What do you think this get module is going to tell me that it's part of? Unnamed, right? It's null because it doesn't belong to any module. If you ask for the name, it'll be null. It's an unnamed module. That's where it's going to be. But we'll prove that in just a second. Let's grab this one right now, go to the second, and here, let's go ahead and say this is second, and we'll print that also. So let's go back and run the code just to illustrate this point. When I run it, I want you to pay a close attention to the number that's following it. What does the number show? It's exactly the same number. that proves to you that they both belong to the same exact module. That's what I meant by one happy family. They both belong, even though they belong to two different jar files, they are part of one single module, which is the unnamed module that you see right up there. On the other hand, if I go to the exact same code, but I'm going to run this now in the module path, that's my second run, and we'll say echo, and we'll just put a little line here so we can take a look at it. Now when I run the same exact code one more time, notice the difference. The top is the unnamed module, the bottom is the automatic module. So because we ran it in the module path, it became an automatic module, and the name is first versus second. They are completely different modules at this point compared to what they were a minute ago. Well, having said that, let's move on a little further now. What I want to do is go to the first directory and notice com, and then under the com, of course, is the path, the package structure I have. This information is important to keep in mind, is that right under the first, but one level above the com, so at the same level where the package is starting, you want to define a module info.java. That module -info is a completely unconventional name for a file, and that is going to contain your module information. So module info.java, what do I want to do? I define a module right there. What's the name of my module? I'll call it the first. You can call it com dot, whatever you want to call it. Names that you provide should follow the same convention like packages do, but I'm going to just violate that for a minute. I'm just going to call it as the first, but I should have really said com.agiledeveloper.blah, blah, blah, and then provided the name for it. That is my module name that I provided in the module info. So this is called the module descriptor. Similarly, I'm going to go to the file second, and right at the same level as the package is starting, I define a module info.java. So what am I going to do here? I say module, and I will call this the second. That's the name I'm going to provide for this one. Now, before we get too eager to execute it, let's remove the execution, just focus on compiling for a minute. Now, at this point, this code would no longer compile. Why not? Because remember the handshake. The rules of the modules kick in the minute you define a module info file. The first is not exporting anything. The second is not requiring anything. They don't have their hands stretched out. There's no handshake. So what's going to happen when I try to compile this code? Well, first of all, I compile this code and put everything into this jar, but I come to the second piece of code, and I'm changing the class path to -p to say that I'm providing it in the module path. That's all I did. So now I go back and compile the code this time. Let's see what the error says. The error says error package first, it is not visible, and it complains at the first, and it simply tells me you cannot use it because it's not visible. And then it says first is declared in the module the first, but the module second does not read it. Let's give credit where it's due. For the first time ever, an error message even I can understand, right? That is amazing. Usually when an error message shows up, I call 7 colleagues for their opinions, and everyone gives their own opinion. Well, this kind of lays it out pretty nicely. It says, look, you haven't made it visible. I can't really use it from here. Sorry. So what am I going to do? I'm going to go to the first module info.java, and I'm going to say in here export, and exports what? Com Agile Developer first. You export your package that you want to export on one side. And now we have a little extension of the hand. The first says, I'm going to give you my package called first. Let's pause for a second and think about it. Packages can be exported. Now, if a package is not exported, the classes in the package, even if they are public, is no longer public. So that's the very first thing to keep in mind. Public is no longer public. Public plus export is public. Public without export is not available. You cannot use it. So that's the first thing we did. Now let's go back and do a build one more time, see what the error says. The error says that the first is not visible. First is declared in the module, but the module second does not read it. So it says, look, he's extending the hand, but you're not really receiving it. You need to change. So what am I going to do then? I'm going to edit on this side now, second module info. And I'm going to say over here requires, and what am I going to require at this point? The first, because that's the name of the module that I'm interested in using on my side. So now I go back and compile this code and notice that there was no error. So on one side you do the exports, on the other side you do the requires, and now everybody is happy to use the one that's provided, and that's how you export it. Now obvious question is, what if it's a third-party code you are using? What do? The short answer to that question is, you want anything that wants to use something should require it. Now there is one little approach called the transitive approach, and I highly do not recommend using it unless you are breaking what I like to call as a ball of mud into smaller pieces. This is never a good idea to use transitive for third-party libraries. Use transitive when you have a big ball of mud and you want a few months to refactor this mess so you can start using transitive during the transition. So I often recommend people use it for internal stuff, not for third-party dependencies. Now that this compiled, how do I go back and run this code? Well, to run this code, what I'm going to do is to say java minus p, and of course output / mlib directory, because that's where my modules are sitting. And then I say minus m, the second, because that's the name. How do I know? Again, I don't want to be guessing. Jar minus f, output mlib second.jar minus d says that I have a module info, and my name is actually going to be the second. That's the name we provided for it. So you can remove all the guesswork by using the minus d option, and it says that that's your name. The second is the name of your module, so I say minus m the second, and of course this is going to become Agile Developer second.second. So when I go back and run the code this time, what does that do? Now notice it tells me, but my second module, second is part of the second module, first is part of the first module. Now I know, you as programmers, you never take these things and walk away. I can see the curiosity in your face. You're like, but what if I take the new stuff and run it in the class path? Well, okay. So if I go back over here and take this stuff and run this in the class path. So I'm going to say minus class path and then specify first.jar colon output / mlib second.jar. But clearly, because it's the old stuff, there is no minus m option, and you're going to simply run the second. Anyone wants to take a guess what is going to happen now? Bingo, give me a high five from there. That's absolutely correct. It becomes an unnamed, you lose all your privileges. When you go back and run in the class path, you are absolutely correct. Thank you for that. So when you run this code, notice they both became unnamed modules. So in other words, when I said earlier, all the stuff in the class path, that's not entirely true. Anything in the class path belongs to unnamed module. Old stuff, obviously, but I don't know why you would take that beautiful module you wrote and put it in the class path, but if you do, it gets condemned to become part of the unnamed module as well. So far, so good. So we covered the groundwork. The next 15 minutes we have with us together, I want to talk about some rules. I apologize I won't be able to write code for those because of the time limitation. I typically give this talk over 90 minutes to 2 hours. I'm trying to compress it in here, but I'll talk about stuff that we need to do. So we talked about some of these things here. Now let's dive in and talk about some rules. Any jar running the class path is called an unnamed module. Thankfully, I showed you that code a few minutes ago. You saw that working. Any traditional jar running in the module path is called an automatic module. I showed you that as well a few minutes ago. We took our traditional jar and ran them in the module path. Any jar with a module descriptor, when run in the class path, becomes unnamed module, runs in the module path becomes explicit name module. I showed that part also to you already. Now, modules cannot share packages. So if you have a module M1 and it contains package P1, and module M2 also has package P1, what's going to happen? Well, if they both are in the same module path, you will get kicked out. Your program will not run. And Java will say, something is really smelly here, what's going on, out of here. And it will terminate right away, it won't run any further. Now, I forgot about one thing I want to quickly show you here. Let's go back to this code really quickly and run this. And notice when I ran this, you can see that's the output we got. Now let's go back and run this from the command prompt one more time. You can see the output. Now I remove output/mlib first.jar. I got rid of it. If you look over here, the second is there, not the first one. Now if I go back and run this, what will the old Java do? It will start running, isn't it? And it will start running until that fateful moment when your code requires that particular object is going to get a class definition not found exception. Well, here's the good news. In the case of Java, the module dependencies are part of the metadata. And you saw me use that -d option and examine the metadata. Well, because it's part of the metadata, both the compiler and the runtime can examine that metadata, and they do. And as a result, when you start a program, it immediately verifies the module graph. And the module graph should have all the dependencies wired together. If something is missing in the module graph, it immediately stops and says, sorry, I cannot run. It gives you an initialization boot layer, find exception, module the first was not found, required by the second module. So that is what I was saying earlier. It runs in the mother mode. It immediately tells you, you're walking without the key, don't go, here, take it, and don't leave without it. So it gives you an immediate feedback, as you can see. And the reason it's able to do this is because it pulls that information from the module graph, and that is available to you at all the time, and both at compile time and runtime. So it looks at the modules and says, look, you cannot have a split package. It doesn't allow you to do that. Unnamed modules can talk to other unnamed modules. That's a broken English right there because there's only one unnamed module. So what I really mean is classes within unnamed module can talk to classes within unnamed module. So what that means is if you have a piece of code right here, this code can happily talk to this code in here, not a problem at all. So because everything in the unnamed module can talk to unnamed modules, not a problem. That's basically what you have. And you saw that happen a few minutes ago when I ran the code. Automatic modules can talk to other automatic modules. So what that means is if I were to create an automatic module right here, the code within this automatic module is allowed to talk to the code within yet another automatic module. This is perfectly fine. There's not a problem to do this. So this is again made possible, and you saw this happen earlier. I took the two old jar files, put them in the module path and ran them, not a problem at all, because automatic module can talk to other automatic modules, not a problem. The next rule is automatic module can talk to unnamed modules. So if you put something in the automatic module, it can talk to an unnamed module. So what do I mean by that? If I don't have the module descriptor, if I take the second and put it in the module path, and I take the first and put it in the class path, not a problem, because the second can talk to the first from the module path to the unnamed module in the class path. That's perfectly fine. So what I mean by that is this is perfectly fine, not a problem at all. So you can certainly do this. So this is possible, not a problem. On the other hand, the unnamed module cannot talk to an automatic module. In the example I showed you, if I don't have the module descriptor, but I put second in the class path, I put the first in the module path, the code will not work. So in other words, think about it as there is a one-way mirror between the module path and the class path. The folks on the module path side can see the class path side, but the people on the class path side cannot see anything on the other side. It's a reflective mirror. So basically, what's on the class path cannot use what's on the module path. What's on the module path, when they are within an automatic module, can use what's in the class path. So that is a hierarchical boundary. So old stuff cannot talk to the new stuff, but the new stuff limitedly can talk to the old stuff. So that becomes a nice gradual transitioning ability. So what am I saying right now? What I just said here in those many words is that you cannot do this. So if you try this, this will fail. So I'm going to put a little X over there to say you cannot do that. So you are not allowed to talk from unnamed module to automatic module. You cannot do that. So you cannot cross that boundary and go. You'll get a compilation error. In fact, the error is even funny. It'll tell you, I don't know what you're talking about, because it pretends that it doesn't even exist. So when something is in the module path, the search happens only in the module path. It never looks in the class path. So you'll get a class not found error during compile time because it doesn't even reach over to the class path and look for it. The next thing to consider here is that an explicit name module can talk to other explicit name modules. So what this means here is, if you create an explicit name module over here, that explicit name module that you just created here is perfectly allowed to talk to other explicit name modules. That's not a problem at all. This is perfectly fine. And that is permissible, not a problem. An explicit name module can talk to automatic modules, whereas an explicit name module cannot talk to an unnamed module. Let me put that in the picture. What I'm saying is, this is okay. So you can do this. So this works. But what is not okay is this. So if you try to go this direction, that will not work. Again, I put an X to say that you cannot really do this. And notice the difference. Automatic module can talk to unnamed module. On the other hand, an explicit module cannot talk to an unnamed module. So once you are elevated to an explicit module, you can only speak within the module path. You cannot look outside the module path. So you can clearly see the grandfathering they have done here. Old stuff runs the way the old stuff are. You can transition to the new world. You have a little temporary permit to go from the new world to the old world, but you elevate yourselves to an explicit module. You can only talk within explicit module. Now, this is not going to happen before I retire or die, but in my vision, I can think of a day when there is only module path and there is no class path at all. But those damn legacy code, they're going to be there for a long time, so that's not going to happen for a long time. But in an ideal world, you will only have module path and no class path at all. And in that case, everything is within the module path and not with the class path in that regard. And then next thing to consider, an explicit name module has to require any module it needs. So the minute you define a module descriptor, you got to tell what you want. You cannot use what you don't ask for, and including automatic module names. So please give decent name for automatic modules, unless you hate the people that you work with. Then you give any name you want to and make them suffer. But give a good name minus D option. Now, one thing they recommend is, if you're going to be transitioning, if you're not ready to go into an explicit name module, you don't have to do much, but at least open up the manifest file, and in the manifest add an entry called automatic-module-name, and give a decent name for it. Your jar file can be any name. Once you have the descriptor in the manifest file, that name will be used as a module name. And that's another reason why you want to use the minus D option and not look at the name of the jar file, because a jar file may have some name, but it may have a module descriptor, it may have a manifest declaration that gives a different name for it for the future that they want to start claiming right now and start using it. And that is something you need to be careful about. An explicit name module exports only what it specifically exports. So if you have an explicit name module, you have to tell what you export. If you don't export something, that's not visible for the outside, and they cannot use it. Automatic module, on the other hand, are very generous. They export everything they have, and they require everything they use. Obviously, because this is old code, so it uses the default for the grandfathering purpose. So an automatic module automatically requires everything it uses, and it also automatically exports everything it has. So in that regard, one thing I didn't cover here, what is your inference? Can an automatic module talk to an explicitly named module? What do you think? In other words, can this arrow go in the reverse direction from here? Take a wild guess. I'll give you a clue. The answer is yes or no. It cannot, unfortunately. Good try, though. It cannot. So, so it cannot because in this case, of course, explicit has the rule. It only exports what it actually exports. That rule presides. So you cannot talk from automatic to explicit. You can only go in that direction. Now, all this has very significant ramification. I've got 5 minutes to tell you all about it. So what is the deal then? How do we start from legacy and go forward? Let's let this sink in for a minute. This dependency has ramifications. You cannot just take things and randomly put them together. So what do you have to do to transition from old stuff to new stuff? How do you really make this happen? Well, imagine for a minute you have this condition where you have a jar 1 depending on jar 2, depending on jar 3, depending on jar 4. If that is your hierarchy, how do I transition? Now, the reason I want to mention this is not intuitive. A lot of times we may say, oh gosh, this is very easy. Take the one that has the least dependency and start moving it. Well, in this case, that's not unfortunately true. Why not? Because of these rules, what can depend on what matters, isn't it? Now think about it. If I take jar 4 and I put it into the module path, let's say, and I keep jar 3 in the class path, what will happen? It won't work because what's in the class path cannot talk to what's in the module path. So you cannot start in the tail end. It completely defies the logic we normally use. Hey, jar 4 doesn't depend on anything. Attack it first. Sorry, that won't work. Because if you elevate that to module path, what's on the class path cannot talk to what's in the module path, isn't it? So what you have to do is start on this end and make your transition. And this becomes easy to understand if you stare at this dependency for a while. It makes logical sense after that. That's why this dependency is important. So what do? First of all, you take the code, the legacy code. Java 8, Java 7 stuff, take your legacy code. What's the first thing you do? Run them all in the class path using old Java. Why do I emphasize it? Because as number 1 rule as a programmer, you never touch code that doesn't work because it becomes your liability at that point, right? So I always say, does it work? They say, yes, show it to me. And they show it to me, it works. Now I'm like, I'm touching this now, right? And it better be in the version control as well. So never touch the code when it doesn't work. Make sure it's actually working. Great, it's working. What do I do next? Run them all in the class path in the modern Java. Now, what could possibly not work here? Any ideas? Missing libraries, possibly. Anything else? Split packages. If your package, missing libraries is a really good point. Hey, I'm using Corba, they don't have Corba anymore, as an example, right? So that would be an issue that you need to look at. I jumped a little ahead. So you're right, it's a missing libraries could be a problem. You got to be careful. Also, potentially, any other incompatibilities you may possibly run into, you want to verify that. Then run them all in the module path. What could possibly go wrong here? This is where the split packages come in. I jumped a little too early for that. So this is where the split packages come in. If God forbid, if your application contains packages that belong to multiple jar files, that's going to kick you out at this point. So that's going to be a problem. Hey, all that works. What do I do? Sorry, say it again. Name clashes. Well, packages are the unifiers in this case. So that shouldn't be a problem. As long as the package names are different, it shouldn't be a problem. Oh, got you. No, you can't do that. So yeah, you're right. So if the jar files have the same name, I mean, tough luck. Yeah. So yeah, you're right. So that could be a problem as well. Given the names, so what's going to happen is, if they're in different directory, one will take precedence, the other gets kicked out. So that's why you have to be careful about it. That's why you want to run this and make sure it's working as well. But point well taken. Give names to automatic modules. You want to give them good names and say, here's the name moving forward. I'm not ready to give you an explicit module yet, but here's the name, and give it a name for it to use. Then start converting from the top to the bottom. Start with the jar 1, and then jar 2, and then jar 3, and work your way that way moving forward. And that can be the transition path to make this work. So some of these rules are very important to keep in mind. I know there was a crash course on it. Hope you got something out of it to take home and think about it. Hope that was useful. Thank you.